All right, so with function notation, we have g of x equals x squared minus 3. And I want to know, what is g of negative 2? So the one thing I'm going to do here, okay, is I'm just simply going to replace my x with the negative 2. Now notice my negative 2 is in parentheses. So when I plug it into my equation, I'm going to plug it in parentheses. So g of negative 2 equals negative 2 squared. Well, that's going to be negative 2 times negative 2. That's 4 minus 3. So g of negative 2 is going to be 1. Oh boy, you are here. All right, so we have g of negative 2 equals 1. And as I said, this corresponds to the point negative 2, 1. Okay? Jordan, the only thing you missed was we started out class with a CFA in Schoology, so you could do that whenever. Okay? All right, so that is the function notation there. So let's do A together. Sophie, what's going in for x? 3. And I'm going to put it in what? In parentheses. So f of 3 equals 2 times 3 squared minus 3 times 3. All good with that? Now, I'm going to follow order of operations, and I'm only going to do one thing at a time. So 3 squared is 9. Then I have minus 3 times 3. So f of 3 equals 2 times 9, that's 18, minus 9. So f of 3 equals 9. So that corresponds to the point 3, 9. Now, here's something you guys have to know. When we're doing function notation like input-output tables, if I want to know what is g of negative 2, I'm probably not going to use my calculator for that. I'm just going to plug it in, and I'm going to simplify. Here, with f of 3, I'm just going to plug it in, and I'm just going to simplify. Now, the one thing you guys have to know is this. Well, what do I do when it's asking for, like, multiple numbers, okay? So there's a couple things I can do when it's asking for multiple numbers. In this case, it's giving me a graph, so it's going to make my life very easy. But if I didn't have this graph, if it was just like, hey, what is g of negative 2, and what's g of 3, or what's g of 4? What I'm going to do is I'm going to plug this into my y equals button on my calculator, and I'll show you what that looks like. And then I'm going to go to my table. I'm going to refer to my table, okay? But if it's just asking me 1, I'm just going to kind of plug it in and not worry about using my calculator. Now, how do I do it when it's giving me a graph? I actually think the graph's a lot easier because it's just asking you, what is the value of my graph at 0? So here's what I do. I go to 0 on my x-axis. And then I'm going to trace this up or down until I hit my red line. Liam, what is that number right there? Yeah, look at your graph. So put a point at 0 and then trace it up to your line. That's what I'm talking about. 3. So f of 0 is 3. Let me see if this helps. Liam, does that help at all? Yeah. Okay. So f of 0 is 3. AG, what do I do for 1.5? Well, I'm just going to put a point at 1.5, which is approximately halfway between 1 and 2. Do you see that, AJ? Yeah. And then I'm just going to trace this up until I get to my graph. What number would that be? 5. So if we were talking about 1, it would be at 5, right? So we're going to be, let me show you. We're going to be halfway between 1 and 2. 6. So halfway between 1 and 2. So right down here. So that's 1. So go halfway between That's 0, and that would be 1, right? No, 1.5 would be right there. Now trace that. Cool. You see that? Okay, so we're going to be putting this point on my graph. So at 0, you point there, and you trace it up. You see how we got that point there? Until where it touches my line. All right, so we're going to get, for f of 1.5, we're going to get 4. And then let's go with Nate. Nate, what do we get for f of negative 4?
I don't have it yet. I don't.
Okay. So let me know when you put a point at negative 4. And then trace it up to your graph.
Oh. Would it also just be 4?
Yes, very good. So there's negative 4 on my x-axis, and then I just trace this up until I hit my graph, and I get 4. All right, little different, right? It's just interpreting a graph. This is my input. So these would correspond to the point 0, 3, 1.5, and 4, and negative 4 and 4. All right, Emma. What is the value of this function at 0?
Is it like 1?
It is 1. So we put my point at 0, and then I trace it up until I hit my graph, and it intersects my graph at the point 1. You looked me in the eyes, it means I have to call on you, Jordan. All right, 1.5, Jordan. So there it is. Trace it up. 3. Very good. And then Harshan.
Yeah.
At negative 4, what is the value of my function? To find negative 4 on your x-axis, and then we're going to trace it up. What point is that, Harshan?
Hold on a second.
Okay.
4.
Well, follow this over. Do you see where my arrow is?
Oh yeah.
Follow it over to my y-axis and tell me what number that is. So Harshan, what number? See this point right here where my red line and green arrow touch? Follow that over. What's that number on the y-axis?
Oh, 2.
Not 2.
But I can't really see it.
Are you looking at the screen or your notes?
I'm looking at the screen.
Does that help, Harshan?
Yeah, it's 1.
It is 1. Okay. So we had, here's what we did. We put a point on our x-axis, and then we traced it up, and we got 1. Then we made a point at 1.5, and we traced it up, and we got 3. Then we made a point at negative 4, and we traced it up, and we got 1. All right. Destiny. For 0, where would we be? What is the value of our function? What was that? Negative 5. Very good. Hope, What about at 1.5? Not 2. I think 2 is a little past that. Well, I think this one's tough, right? Because it's like right in between, right? And it could be like 0, it could be 1, or it could be 2. I actually think here, if we look up here, do you see how that looks like it's halfway in between the two boxes? I actually think that 1.5 corresponds with 1 here. That one's really tough to say, okay? And then what about -4? Let's go with Kevin. Kevin? All right, let's go to Jack. Jack? Can't win. Can't win. Who else do we have? Mackenzie?
Is it 1?
Mackenzie?
Yeah.
What would the value be at -4?
1.
What did you say?
1.
1. Very good. Because we're just going to trace that up to get 1. How you guys feeling? Pretty good? All right. Let's turn the page. Now, typically I want you guys to do these on your own, but I think it's a good time to show you how to do these problems, okay? So this is a keystone constructed response question. Now, if you have a graphing calculator, I recommend you get it out. Uh-oh. Is this gonna pop up? Nope. All right, here we go. All right. Let me see if I can get this situated for you guys. Okay. So we have our graphing calculator and we have this problem. It says the pizza place charges for pizza and adds a delivery fee. Typical pizza place. The cost C in dollars to have any number of pizzas delivered to a home is described by the function C equals 12p plus 4. So let's talk about what does that equation mean. And Sophia,
Yeah.
Sophia, what does the 12 stand for?
The number of pizzas.
Okay, it does have something to do with the pizza, but C stands for cost. So would the 12 stand for the number of pizzas or something else?
Something else.
Okay, so P is going to stand for the number of pizzas. So 12 represents the what of a pizza? What could 12 represent, Sophia? Well, that would be the 4. The 4 is the delivery fee. What else could the 12 represent? Could it represent the cost of each pizza? Could that be possible?
Yeah.
All right. So the P represents the number of pizzas. 12 represents the cost per pizza, and 4 represents the delivery charge. So here's how we're going to do this. We need to fill in this table, right? It says a cashier at the pizza place wants to create a table to quickly identify the total cost for an order based upon the number of pizzas ordered. She began the table but was unable to finish it before she left. How convenient for us, right? Complete the table and explain your work. Now, I could do this just like we did for the problems earlier, where I take 1 and plug it in. Okay? And then I take 28 and plug it in. But where do they go? Well, the numbers on the left, they're easy. They go in for P because it's the number of pizzas. But 28, that goes in for C, and I have to work backwards. So the easiest way to do this is we're going to take this equation right here, C equals 12P plus 4, and we're going to type it in. So everybody type in 12P plus 4. So we're going to type it in as 12x plus 4, because we're going to replace C and P with X and Y. And then we're going to come up here to the table. So in order to get the table, I hit second and graph. That brings me to a table. Now, why would I do it this way? Well, watch this. All right, 1 pizza. Well, 1 pizza corresponds to the 0.16. So 1/16. See how easy that was? Judging by what's on the board, Angela, could you tell me another point? Like another line in the graph or in the table?
452.
4 and 52. That's corresponding to right here. We look at for 4 and we found 52. What else should I pick on? Andrew, can you give me another point? Andrew?
Like any number on.
So notice we have 1/16, which corresponded to the point 1/16. 4 and 52. See 4 and 52? Can you fill in like this one, or maybe this one, or this one?
2,
2 corresponds with what?
28.
2 and 28. Very good. So instead of looking at the X column, well, now Andrew looked at the Y column. Let's pick on Drew. Can you give me another one?
124.
How did you get that? That's not even on it. Yeah, but how'd you get it? Did you do something different? Notice I only have 0 to 6. What did you do to get it? Scroll down. So if you want other points, and I know it seems simple, but a lot of people forget that you can scroll and you can move your table. So now I can see 10 and 124. And the last one, this is pots. What's the last one, which corresponds to 64? 5 and 64. Now, do you see why having a graphing calculator is a lot more beneficial? Liam, I know you don't have one, so I'm going to pick on you. Do you see the benefits of having it? Not charged? It's the worst. It's like worse than not having one. I'm just joking with you. Liam, but do you see the benefits of having it? Like you see how quick that problem was? It was pretty beneficial to have it. Now it says, complete the table. We did that. Explain our work. Well, our work, I'll scroll this up. Our work would be quite simply this. Oh no. It would be, ready? This would be what Sophia said. Each pizza costs how much money? $12. And the delivery fee, is $4. That's pretty much all your work, right? So what did we do? All I did was refer to my table in the calculator. Okay? So if you didn't have a calculator, AJ, you would just say, I just plugged in 1 into P. Like you're just trying to explain to them where your work came from. All right? And basically, like they want to see you use your tools. All right. I have to delete that for the next class. All right, now it says create a graph. And this is all I got. What should be on my x-axis? Pizzas. Hashtag pizzas. You know that a hashtag stands for number, right? Or the pound sign. What goes along the y-axis? Cost. And that's in dollars. And what do I do? How do I create it? I just do what? You guys have the benefit because you can see it on one side of the page, right? What am I plotting here? Oh, man. You guys are all like going to sleep because it got nice and warm in here. All right, Jordan, let's bring it on home. 1 and 16. So we're going to plot 1 and 16 to the best of our ability. Now I'm counting by tens, so 1 and 16 is going to be like there, right? What was the next point I need to plot? 2 and 28. That one's going to be right here. Next one, 4 and 52. Oh, this thing was doing so good. Any others, or am I good? 5 and 64. Do I need to keep plotting them? Okay. How many points make a line? 2. So once I plot 2 of them, I should be pretty good. I appreciate that you're plotting all of them. Okay. But for my sake, since my computer is going all cattywampus, right? I'm just going to take my line feature. I'm going to do it here. Now, where should the arrows start? Should I just connect it there, or should I? bring it down to the y-axis. Yeah. And this is going to represent, don't forget, this point down here, it's the most important. This is my starting point. This is my y-intercept. This is my delivery fit. And notice I did a pretty good job plotting those points. They're all in a straight line. Proud of myself. All right.